All right. See where we're at. Can't say good morning. I'm going to say this good afternoon. Tom Dimitrovich here. It's Eaton Tech Talk. It is Friday. It is 12 o'clock. It's actually 12:01. And I don't know about you, but I'm ready for the weekend. But I thought since my code panel meetings were done this week, and I'm not planning on traveling right now for any holiday vacation time, I am going to do a Tech Talk Friday, which is Q&A Friday. So we're going to answer a couple questions. I was just on conference call. I haven't prepared. So that's what live is all about. So here's what I'm going to do. I'm going to take a look at some of the questions that came in on some of the older YouTube sites. Today, I have a feeling based on, I'm seeing some questions when I look, I just filtered down, it says new comment on. I'm seeing comments around single line diagrams, incident energy, arc flash calculations, false energy savers exposed, and a few others. So it sounds like we're going to be talking power systems again, power systems analysis and design. And it looks like we're going to have a safety talk Friday. So hopefully you'll have your 70E book. I was just looking to make sure mine's down here, and your National Electrical Code. Hey, Nihad El Sharif, you know what, Nihad, I am so glad that Code Panel 2 is behind us, at least for right now. Thanks, you did a great job yourself. We got through a lot of task group work. I think the task groups made a big difference. And I think that we made some important changes. One of those changes, which I think is significant, is the fact that Panel 2 is looking at making the island and peninsula receptacles optional, not required. And I think that is huge, in my opinion, from a safety perspective. I don't know where your head was at. I know how you voted on that one. And I think everybody supported it. I don't think anybody voted against it. The way we wrote that language for peninsulas and islands was such that you are not required to have the receptacle outlet on an island and peninsula, but if you do, it has to be located in a certain location because of all of those examples that the Consumer Product Safety Commission brought to the table, and they made a public comment, and everybody can go out and look at it. But they showed that after that receptacle was first required back in the early 90s on peninsulas and islands, the number of people who were pulling appliances like deep fryers, crock pots, babies, children, and even elderly, scarred for the rest of their life because of that cord that hangs down over the edge. So we made, I think, a big decision, and none of us, everybody on the Code Panel 2, I believe, realized the magnitude of the decision that we were making. And I think that it was the right thing to do based upon the data. Hey, we got Nikolai Tesla in the house. Great to have you, Nick. And you too, Nihad. And we and I supported it as well in the first draft. But you know what we needed, Nihad? I think we needed that time period to do our homework and sharpen our pencils to make sure we're making the right decision. That's sort of the beauty of the process. So that's going to be something I think a lot of people will end up talking about in the future. All right, so let's take a look at some questions because Nick is in the house, and when Tesla comes to town, It's time to get this this show on the road. All right, so let's. You know what? I think I like. Not sure where I like what I like better here. Looking at my emails that came in, or looking at the. I am. You know what I'm going to do? I'm going to go to Studio here, and I'm just going to look at some of the questions that came in on YouTube. And here's how I do it. I go to comments, and I scan down because I haven't done a Tech Friday in a couple weeks, at least 2 weeks, maybe 3 weeks. I think it was 3 weeks ago, because I'm looking here. I got comments from 3 weeks ago and 4 weeks ago. All right, so here we go. Info from manufacturer. 100% of LEDs, they are liars and will submit. The serious, wow. Some of you guys got some powerful comments. They seriously deficient in engineering morals. Oh boy, I'm not going to go there. Just an FYI, it was 310K. Matt, let's see. Thank you. Thank you, sir. I got the scanned copy from your link provided. I am currently doing my thesis for professional exam. I checked over my hand calculations too. It's great. So this was in regard to the fault current calculation lab. And if you're not familiar with it, my suggestion is to take a look at the, move this over here because I'm not seeing comments on my main stream here. So if you're not familiar with it, take a look on my YouTube site. I did a manual hand calculation of available fault current, short circuit currents, and I used the per unit method. Not too many people understand the per unit method, but I think I personally, per unit was developed many years ago. Fortescue, CL Fortescue developed that process. I think it was Fortescue with per unit. It might have been symmetrical components. But in any case, per unit helps us simplify our math, and it is a great tool. And if you don't know how to use per unit, it is worth your energy in understanding it, and then do some sample calculations. So that's what I do in that fault current calculation lab, which I think, yep, I think that I can put the link to it. My fault current calculation lab copy. I'm going to drop it in the chat box here, because if you haven't done a hand calculation of short circuit currents, in my opinion, it's worth it. It is worth your time to do that calculation. And I'm going to put it over here on my chat here. I'm going to comment. Control V. I put the link on my LinkedIn site. And I think I could do it on my Facebook site too. This is the bad thing about running your own show. You don't have people to do this stuff for you. But that's okay. There we go. I'm putting it in all three of those areas. All right, so that was that comment. That was on fault current. So per unit, and I'm glad it's helping somebody do their thesis. That's pretty cool, actually. Do any of the circuit breakers from Eaton makes still have any instructions that say to use rope to bind wires together in high fault current applications? I saw an 800 amp 65 kA rated breaker one time that said this was required if it was used at 65K applications. JW, I know, and I know I've spoken to this before. I don't know of anything in our literature, or I've not seen the literature. I think it might be associated. I think you might find, and I did share in the past a comment about assembly. An assembly division, or assemblies division, publishes information like that. So that might be. And I've published that before, so I don't know if that's an old question, but it seems to keep coming up. So hopefully hopefully we got that. Hopefully we answered that one. So yes, in some cases you should be strapping that. We do provide guidance in from an Eaton perspective, and I would say from any manufacturer's perspective, seek the manufacturer's consult. The NEC does require that when, and this is on my, I did a tech talk on arc flash ideas update. So sometimes I don't like watching myself on programs and the programs that I do. But be mindful that that material is out there for everybody. So this was Arc Flash Ideas, and this comment came in on this on this YouTube video. So I'm going to post. I am posting the link to that. Oh, look at this, William Snyder. Hey, how are you, sir? I'm glad. I'm glad to be back in the hot seat again. Yeah, that's right. Fortescue did symmetrical components. I'm not sure who it was. There was it's in my PowerPoint for per unit. I have a presentation on per unit. So if anybody would be ever interested in talking about per unit, but I think I already did a program on that, if I'm not mistaken. I go to basics, per unit. I think I have to go to power systems analysis and design, and there I go, per unit. We're going to get to the bottom of this, and I believe I did put that information in my slide deck, and no, I did not. Wow. Well, don't do for the student what the student can do for themselves. So somebody got to do some homework. Who was that? So here's the question. Question says the NEC does require, or a statement, that when circuit breakers are of a certain size, documentation shall be available to those authorized as to the location of the circuit breakers. Oh, you know where that's at. JW. JW is on his A game. That is in 24087. And there's a one for fuses too. 24087 says, where a circuit breaker is used on a circuit nope, that's 24086. 24087, where the highest continuous current trip setting for which the actual overcurrent device installed on a circuit breaker is rated or can be adjusted is 1200 amps or higher. You have to follow A and B. A says documentation. Documentation shall be available to those authorized to design, install, operate, or inspect the installation as to the location of the circuit breakers. So, and I think that's it. Yep, as to the location of the circuit breakers. That's where he got that language from. That he says that's usually met via a drawing, if it's met at all. And that's another good point, JW. Unfortunately, a lot of these little details are missed. 24087 is there for the electrical worker. This is there to be able to document and demonstrate and show to the inspectors and others involved that there is an arc reduction technology to provide this electrical safety, and the requirement here is to say where it's at. And JW's point is a point well made. In some cases, some of these things get missed, and you can't blame any one individual. The code is constantly changing. As we're in another cycle again, we're changing it again. Wait till you see the load calculations. Article 220, NEHAD. You were involved with that. That was a significant change, in my opinion. We didn't necessarily change how you do a load calculation, but we changed how the article was written, because in my opinion, there are a lot of people that don't do load calculations correctly, because in some cases, when you look at the language in the code, this is where usability, and I have had this discussion with people, usability of the National Electrical Code does play a role in electrical safety. Some people will say, well, look, there's only so much you can do. And I get it. I understand that. There's only so much you can do in how this book is laid out and how it's written. And you'll hear people say, that the book is not for the untrained individual. I don't necessarily disagree with that, but there is a level of clarity that we can add even for the trained individual to help them understand how to do things correctly. And we made some changes in Article 220 during the second draft of the 2023 code cycle that I think is going to pay dividends in making sure that that load calculations are done correctly. So I think that's a good thing. So JW's point is well taken, in my opinion, that, and remember, everything you hear on here is my opinion. It's not the opinion of NFPA, the code panel members, or any other, or IEEE, any other organization that I'm in. What comes out of my mouth is my opinion, and hopefully what comes out of my mouth is processed before it goes through here. It goes through here first and then comes out of here. But sometimes what goes here doesn't process, happens before what's processed up here. So, but in any case, that's why question everything that you hear and see on this channel. Otherwise, no way to, it says putting boxes around equipment. So this is what he's talking about. And I set up MobiCam just in case. And let's see if MobiCam is working today. I hit MobiCam. Mobi1 Kenobi. Oh, there it is. It was the wrong MobiCam button. All right, so JW says, let me widen this up. JW said that otherwise it's in putting boxes around equipment on one lines is important. Otherwise, no way to tell if a switch is in the same enclosure, a separate enclosure, right next to you, etc. So what he's talking about is when we do a one-line diagram, if I draw something like this, you might ask yourself, okay, Tom, is this breaker A and B, are they in the same enclosure? And they look close proximity to each other on a one-line diagram, and I might show a transformer up here and say, well, they look like that this would be the main and this would be a feeder or a branch circuit. But it very well could be that if I said, well, no, that's my enclosure, and oh, by the way, that device A is in its own enclosure. A single line diagram can offer a little bit more information other than device A is feeding the panel or is feeding the bus that's supplying device B. Because remember, I could have a device C in there as well, etc., etc., etc. But putting those dashed lines around the equipment helps us understand a little bit more than just the power flow through a power distribution system. So that can add value to the single line, and JW is saying that here. And otherwise, no way to tell if a switch is in the same enclosure, a separate enclosure, right next to you, or a mile away. He says, I've had it happen where you are planning a service job and you really can't tell. And I'm with you, brother. I am absolutely with you. Oh, and then I did a couple live at PSEX. If you haven't seen that, well, which can be actually I went live on my phone. I've got to figure out a better way to do that. But I was up at our Power Systems Experience Center, and we had a blast, and we were outside, and I just said, hey, Dan, you wanna go live right now? And so we went live on my YouTube channel. I don't know how well it came out. It was fun. It might make you dizzy. But I've got to get one of those little Mobi sticks that does the balance and will do the flipping and all that jazz. But take a look at that. It's live at, I even spelled PSEC wrong. It's spec. It's live at the Power Systems Experience Center. And I did two live sessions. I did 2 live sessions with Dan. And the second one, Dan was a little bit low in volume because I don't have microphones and stuff. All right, Tom, condition of maintenance and operation conditions are 2 different things. So Robert from Omaha, comment on Q&A. He's clarifying. He says, Tom, condition of maintenance and operating condition are two different things. And I would argue, I agree. So there's no argument. I would agree with that. And now that probably came up with regard to condition of maintenance because 70B and the 70E will reference and everybody, I know everybody out there has a copy of 70E. Talks about how important maintenance is. And what's really cool is Eaton just came out with a really cool product as part of our power defense breakers. If you are not familiar with our new line of circuit breakers, we revised our power defense molded case circuit breakers. I'm telling you, we have what I call the cat's meow. I have now a circuit breaker that will help you understand the condition of maintenance in your circuit breaker. And it's taking a little time to come up. It is just absolutely phenomenal. So if you go out to our molded case circuit breakers, it's called Power Defense. Globally rated power defense circuit breakers. We've got a lot of videos out there on this product. It's got arc flash reduction, built-in communications, and I'm looking for the condition of maintenance because I'll tell you what, power distribution needs to be maintained or replaced. PXR chip units also offer programmable relays. Where is the power defense guarding your dream, your reputation? Here it is, monitoring health. Oh, I'm telling you what, this I think is you think about a circuit breaker, and I just did a circuit breaker basics, a little bit of an introduction on the IAEI's YouTube channel this past Tuesday. It was a recorded session, but remember, check that out. You think about a circuit breaker, very mechanical device. You've got the overcurrent protection and the switch all built into the same unit, so to speak, enclosure. It's a molded case. You've got a lot of different moving parts in there. You've got arc extinguishers. You've got contacts. You've got a physical arm that has to open. You've got latches. So it is a physical device, and they talk about in this, and I'm going to put a link. I'm going to put this on the. I'm going to put a link to this on the live stream. Oh, and I wasn't watching the chat box. Oh man, it says I can't. I'm at 208 characters and I can't get the whole thing. I'm gonna try it on LinkedIn. Nihad, what am I doing, buddy? I'm putting it on LinkedIn. I can post it there. All right, so I post the link to it on LinkedIn, but I got to find a shorter URL for this thing. Dadgummit. Oh, anyway. There it is. All right. So I got they call it a bathtub failure curve. In time and years, it goes up, and for some reason I can't post. In I'm streaming on like 5 or 6 different platforms. So I put it in LinkedIn. I'm going to see if I can put it in. I'm going to put it, there it is. I'm going to put it over here. All right, there we go. And I put it on Facebook, at least one of the sites I'm streaming to on Facebook. Anyway, if you're out there, you got to check it out. Molded case circuit breaker health. It gives you, let's talk about what it gives you. Operation data. The total number of operations can provide indication of the endurance and the wear, the number of interruptions, and the magnitude of the energy interrupted. Very important part of that puzzle. Overload interruptions, obviously. So if I can tell you that this saw so many overload interruptions as opposed to instantaneous, high short circuit interruptions, I'm giving you information. The environmental temperatures. So I can give you runtime, how long that it's actually been on at in a continuous run. So these the trip units give you so much more information that you can help determine the amount of energy or when you need to pull maintenance. And think about what that means from a safety perspective. That means that if I can better determine when I'm going to perform maintenance, if let's say I have only so many people who are going to perform maintenance on a system, I want to make sure I'm utilizing my electrical workers effectively, and I basically deploy them in an effective manner. I don't want to waste their time. So does it track? Okay, so I'm just looking at some comments. I can't get the link in my YouTube site. So does it track all of this so you can download and review periodically? Yes, Robert from Omaha. Yes, you can. Yes, you can. You can communicate with that information. You can download that information, and you can share that information. So it's just how you connect to it. If you have it connected to a computer, so yes, you can. All right. So I'm just looking. I wasn't looking at the comments. Robert from Omaha, thank you for joining us. Nihad says, I'm so glad that there was that many smart people online to learn from. Definitely was the dumbest kid in the class. He said he saw our PSEC videos. Excellent. Yeah, they were short and sweet. Bill Snyder says, my question was why they test breakers in free air. You might have already answered as part of the UL standard. I didn't hear the reason why. Oh, I don't remember seeing your question. Maybe you saw, oh, you know what? It was recorded. I'll have to take a look at that. But you know what? That's a good question. So think about what we typically will do is we do test it inside of an enclosure. We test breakers in free air, but we also test them in an enclosure. For example, in the case, so for example, 80% versus 100% rated circuit breakers. In a 100% rated circuit breaker, I'll not only tell you the size of the enclosure that you need, but I'll also tell you the copper that you need, copper bus, and maybe a high density copper bus at that. So we do test inside of equipment, and that's part of the standards for the assembly as well, like panel boards. We will test the circuit breaker in a panel board because, and I know that for a fact because sometimes we'll develop a circuit breaker and you think it's the greatest thing since apple pie. You send it down to your assemblies division. They put it in the assemblies and they start putting it through the tests where we test it in the assembly and they say, sorry, it's too hot. The temperature rise, you start to fail the temperature rise. So we do test in and outside of an enclosure. So, Mr. Snyder, hopefully, and you know what? Maybe what I can do is I'll try to grab my good friend Lou Grayhor, who does a lot of that testing for us, and I'll do a program on UL 489 and the test and all that good stuff. That sounds like a good program. All right. Let's keep this moving. Whoops. I hope I did not close. I'm going to close that. That's all I have to say about that. Where is my? There it is. All right. So, condition of maintenance: protection from shock. Also, exposed energy, energized conductors and parts. Residential. We have shock hazards. Talked about drones. That's right. I did a session on one of my Q&A Fridays. I borrowed a drone from our experience center. And you know who's going to get their license to be a pilot for a drone? This guy. I'm going to go for my test here shortly. All right. IR photos are very useful, and that's infrared photos. I understand the intent of the windows, but I think that you should be comfortable without the windows, i.e. open enclosures. Don't get near anything, take picture, and close enclosure. Trained personnel. This is from NHC, and I can't remember his name, but it's NHXZBOI. Really now, a stable system is not going to blow up simply because you opened the door. Personally, not going to suggest the overprotective product. Still thumbs up, but I see little prospect for that product line. Not going to invest in that. So here's what here's what he's talking about. He's talking about those infrared windows, and what we were talking about in that Q&A Friday. I was up at the Experience Center, and then I've had some questions about, are those windows rated? Do they have a glass? Can I use my infrared scan through there? Does it matter the type of materials, the honeycomb, all that stuff? So in any case, what this gentleman is saying is that you should feel comfortable taking that panel cover off and exposing the energized parts and conductors. And my thoughts on that too are, I would probably feel comfortable, like for example, my panel board in my house. I feel comfortable. I feel qualified. I feel comfortable taking my dead front off because I know the condition of maintenance of that panel board is impeccable. I inspect my own panel board. I look at my equipment. I test my breakers. So I don't have a concern on removing my panel board. Why? Because I know the entire history. I know when that puppy went in. I know it was a little baby and it was first installed. I know the maintenance that I've done on it. I know the maintenance that I've hired people to do on that equipment. I feel very comfortable with that panel board. But I walk into someone else's home. I walk into another application where I don't know the condition of maintenance. I may not have that level of confidence because I don't know the history. I don't know what any of that equipment has seen in the past. I don't know who worked on it. I don't know when the last time that dead front was off. There are a lot of reasons why I would have a less comfortable feeling, but that's because I'm not as engaged with that specific application or that installation. Now, those windows can save you a lot of time. Think about the amount of time that's invested in removing covers to expose something to do what? Take a camera, scan it, and then you have to close it back up again. So the actual work, yeah, you're not engaging with it, but I can probably think about from a resources. We said about having a circuit breaker that tells you the condition of maintenance. If I looked at my circuit breakers and I said, okay, this thing has been cycled. It's been turned on and off in the last year or last few months. And I can tell you how many times it's been turned on and off, as opposed to the breaker that I can look at and say, look, this thing has been closed for more than a year. It's never been cycled. It's never interrupted a fault current. It's never interrupted an overload. It's not been turned off and then on at all in whatever that breaker is going to tell me. That tells me maybe I should take a look at it. Maybe I want to turn it on and off and take a look at the manufacturer's instructions. But if that breaker is getting use, it hasn't interrupted short circuit currents, it has been opened and closed for other reasons, I don't need to open and close it again. I have documented evidence of that. Now, what did I just do? I have reduced the amount of time that I'm going to expend in my resources. If you're going to perform maintenance on your power distribution system, you want to make sure you take that person's time and use it effectively. So if I can avoid taking dead fronts off and exposing energized bus, which I got to calculate the arc flash boundary and all that jazz, that person might have to really technically be dressed for the occasion, depending upon the condition of maintenance and everything else that's going on. Do I want to take that effort? Do I want to, even if you say, look, he's going to take the dead front off, he's going to take the picture and put the dead front back on again. If you can justify that the likelihood of an arc flash event is little to none, and he's not going to touch or she's not going to touch exposed energized conductors. Well, okay, but you still have the time invested in removing the cover and putting it back on again. I can get through more of my facility by leveraging technologies like that. It's not a code requirement, but that's the way that goes. And then he says, really hate needing the reader glasses. What, now I get it. It says, what a PITA. I'm like, well, what do you got against PITA? PITA, P-I-T-A. Now I get it. I know what PITA is. Pain in the bumbunskis. All right, very standard practice. Assume there is never a termination spec. How many conductors in the same terminal? Very standard practice. Assume one and only one. If you look at some equipment, especially breakers, some breakers will tell you can put multiple conductors. Some terminals, like power distribution blocks, will tell you, here's how many conductors you can put under one lug. But it'll also tell you that, for example, you may not be able to put a solid conductor and a finely stranded conductor or a stranded conductor under the same lug. You might not be able to put a very large conductor and a very small conductor under the same lug, because you'll lose that pressure, that connection. So it's very safe. You're still safe to assume. If you assume one conductor, one lug, then you're doing good, as long as the conductor size will fit appropriately and is listed for that lug. But in many cases, we might need to put more than one conductor on a termination. And my message there is, follow the manufacturer's instructions. Many terminations will tell you not only how many conductors you can put, but the size differences, and quite possibly stranded versus solid. You might not be able to mix those. So just be careful. The moment you are going to put more than one conductor under a lug, that's a flag. Read the manufacturer's instructions. Do your homework before you take that action. All right, JW. Can't read the code book without glasses. Telling you, man, they're getting smaller. Remember when, I think it was 2014 or 2017, that they shrunk the font of the NEC? They did? I did not know that they shrunk the font. The average age of the electrician continues to rise, but in order to hide the fact the standard keeps growing, they shrunk the font instead of adding more pages. So JW wants more pages and bigger font. I'm in the same ballpark as him. Maybe one day I won't need these, but I'll tell you what. And you know what gets me, JW, is the informational notes and the exceptions. I think the exceptions are small because nobody wants you to leverage the exceptions. And the informational notes are small because they know that the older guys already know that information, and the younger guys who have the good eyes can read it. So the older guys don't need to read the informational notes. I don't know if that's the message they're trying to say, but I'm telling you, for me to read the informational notes, these things work very well. Now, I will, and we did a session on IAEI's YouTube site. You got to check that one out. It was last Thursday evening. It was a 5 o'clock Thursday evening. I actually did it on IAEI's YouTube site with Eric from NFPA. And I can never remember or pronunciate his last name, but Eric and I covered, here it is. I got his card. Eric Hohengasser. He and I looked at NFPA Link. And I wasn't a big fan of NFPA Link when it first came out. And the reason is because I like to read. I like paper. So, so anyway, check out that IAEI's YouTube site session on NFPA Link, because I'll tell you, JW, you can expand and change the font size to whatever your little heart desires. And you can even do it on your phone. But I'm telling you what, no matter how big the text gets on my phone, I got to use these things for my glasses too. I see Daryl Hill's name. Daryl Hill. Guess what, Daryl? I've been playing with a drone. Yeah, I'm going to fly. You see this bird right here? And I'm getting my license, Daryl. I think it's called 10 CFR whatever 107. It's a 107 license. So for a drone pilot, remote drone pilot, I am going to sit for my test. I don't know if you've ever taken it. Let me know, Daryl, if you have. And I know you have a drone, but I'm gonna do it. So, but I want to fly that drone right behind me, right down there in the Berg, and we're gonna get some cool shots. Daryl says he sent in, 107. I sent in a PI between the 17 and 2020 on font size. CMP1 said it was a publisher issue, and it got shot down. Ooh, man. Well, Daryl, you know what that's called? That's called a shot across the bow. And I would agree. What about voltage surge or something else? I got to look at these. My question was, what does it track? Yep, we talked about the documentation is everything. Think again, had an event where just opening a switchgear door caused an arc flash. And you know what, Robert? That's okay. I've been in those scenarios as well. And that's why I say the more you know and the more intimate you are with your own equipment, and the more quality, from a qualification, but mistakes can't happen. When you're taking the dead front off, I think I know I've been there, and you guys have probably been there too, where if you got to hold that, you take the last screw off, and what do? You put your pressure on the door, you take the last bolt out, especially when you're by yourself, and then you got to hold it and then pull it off, and then those panel board covers are never just straight; they're always like torqued a little bit. On a residential panel board, but yeah, I would tend to agree with you, Robert, that when you start to expose energized parts and conductors, qualified person makes a big difference, and you are putting yourself in harm's way because you're exposing bus. So very good point. What about a voltage surge or something else that causes an event? Never comfortable with exposed live parts. You're absolutely right. Never comfortable with exposed live parts. All right, so let's go back to questions. Sorry I missed the live broadcast. Okay, we already read that one. On the Chapter 9, Table 9 question, in addition to the insulation versus uncoated wire, so Chapter 9, Table 9, I know where this is going. I haven't read the question yet, but it's JW. Chapter 9, remember Chapter 9, Table 9, if my memory serves me right, that is your impedance values. So you got to go back to Chapter 9, not informative annexes. Don't make that mistake. I used to go back to the informative annex, but Chapter 9, Table 9 is on page 70-706, and it is the alternating current resistance and reactance for 600-volt cables, 3-phase, 3 single conductors in conduit. Back over to the question. On the Chapter 9, Table 9 question, in addition to the insulation versus uncoated wiring thing, and remember, this was a question that came up during that Q&A Friday, where the notes say, these values are based on the following constants: RHH wires with Class B stranding in cradle configuration, where conductivities are 100%, IA is copper, uncoated versus coated. Oh, that's what it was. In the title, it says alternating current resistance for uncoated copper wires. That's in the title of the table. You have the reactance for all wires, and then you have the alternating current for resistance. So he says, in addition to that, because our question was, and I haven't answered it thoroughly enough for me to be able to convey that, which I will be reaching out to somebody. And I might reach out to David Mercier, who works for UL now, who used to work for Southwire. David has probably forgotten more about conductors than anybody in the conductor industry has ever remembered. So But in any case, he says, in addition to that, why does the type of insulation matter? Period. And he spelt out period. The insulation type can affect capacitance, but not inductance. And the note 1 also says that capacitance is ignored. Because note 1 says these values are based on the following constants: UL type RHH wires. And what is an RHH wire? So how do we know that? We go back to 310, and they just recently moved that table in 310. It's 310.4a, and we got to look for RHH. RHH is moisture resistant, flame retardant, non-metallic covering. RHH is the type, and the application provisions are for the trade name is thermoset. So it's a thermoset insulation. RHH wires with class B stranding in cradled configuration. Wire conductivities are 100% IACS copper and 61% IACS aluminum, and aluminum conduit is 45% IACS. Capacitive reactance is ignored since it is negligible at these voltages. So JW is pointing out that why does it matter? I mean, and then the question would be, if I have a different insulation, there's no multiplying factors that changes the impedance value. I don't have an answer for that one. I have thoughts in my head that I would love to convey, but I want to reserve any comment on table 9 until I get a guy like David Mercier on this channel, or maybe on the IAEI channel. Stay tuned for that one. Maybe I get a panel of experts for IAEI News Live when we talk conductors. Stay tuned. Coming to a BAT channel near you. Here's a reason not to use 3-phase panels on a single-phase application. If someone accidentally puts more than one 2-pole breaker in and has one stab connected to the unused phase, it will create a circuit with the same voltage in irregularity problems that can exist with an open neutral. Very good point, JW. And this was a question with regard to the comment of using a 3-phase panel in a single-phase application. Was there any code that says you can't do that? And no, there wasn't any code requirement that says you cannot do that. And I even thought about the standards perspective. There's nothing in a standard that says it shall only be used on a 3-phase application. I wouldn't recommend it. But I've seen it happen, and I've seen inspectors ask that question because you know what happens. You got I have to get this done. I have to do it quickly. They had a 3-phase panel that they weren't using. They installed it. They did a single-phase application out of it. The inspector scratched his head, said, well, I don't know if this is right. The voltage levels were fine, and there's nothing in the code that prohibits it, so they would have to permit the use. But it just doesn't look right, doesn't smell right. And to JW's point, if you don't know what you're doing, you can make a pretty bad mistake. JW has an opinion on drones. Opinions on using drones to increase safety. Frustrated, exasperated, underpaid, and micromanaged workers don't take well to feeling like some rich corporate guy is going to surveillance on them when he flies over with his drone, but due to COVID, won't come and say hi in person. That's not good for safety. All right, JW, point taken, brother. And I love your passion. My comment from a safety perspective was, and I did this on my house, I inspected my gutters using a drone. So my thought process, it wasn't watching someone do their work via a drone to make sure they're doing it correctly. My thought process was, can we leverage drone technologies to keep a person off of a lift or a ladder? You know, on my house, to inspect my gutters, I would have to physically get a ladder out, get very high up, and look inside my gutters. I'm an old man now. I used to do that when I was a kid. I need glasses. So if I'm looking at anything close, I'm going to need glasses. if I can, which I did on my house, I took that drone up and I went around every inch of gutter to look inside for looking for any resting water. And I even got pretty doggone close to be able to inspect how it was connected to my roof line. So I avoided, and I've been thinking about this because I've been looking at those gutters. I've never looked up there. And I have some lower gutters that I had to fix around my side porch. And that was easy. That was easy for me to see that it was pulling off. And they used the wrong nails. You know, they didn't use aluminum nails when they put those in, so they rusted. And I'm worried about now my gutters that are high up. So my thought process on drone technology, can we leverage this from a safety perspective, not to monitor someone's work, but really, is there some high up work that we could avoid doing in a lift or on a ladder? I fail to understand why utility companies are not forcing arc quenching switchgear or arc flash detection technology in the project specification. Implementing arc flash detection technology is easy and cost effective. The fault current, and this is from Summit Mondale. Mondale. You're speaking my language, brother. The fault current elimination time is reduced to 40 to 50 milliseconds, irrespective of all the anomalies related, I can't read, related to short time and instantaneous relay settings. So Summit, yes. I would have. So here's the thing on the utility side. Now I gotta get I gotta put on the hot seat is Tim Crawshaw. He's on panel 2 with me and Nihad El Sharif. And so what he's talking about, we had this discussion. Remember, I gotta go to Obi-Wan Kenobi. Where is Moby? There it is, Moby Camp. Remember this discussion. Let's say that I had a service. I've got a utility. And maybe this is a utility transformer. And then what do? I come down to this other big gray box. And I'm not going to draw a dotted line. I'm just going to draw a square. So now I have my service. So this is my utility. And this is utility transformer. And this is my service equipment. Now, what we know about the National Electrical Code is I need a main if that's a panel board, etc. Now, the thought process and what we showed was the incident energy here. The incident energy is through the roof. Why? Because up here on the utility side, which I did not show, I've got a fusible switch. And that fusible switch is on the primary of this transformer, and that's determining the energy at the secondary of this transformer. And we said one way to solve that is to do something like this, to break out that main overcurrent protective device in its own enclosure so that I can leverage my arc flash technology to Summit Mondale's, hopefully I got your name right. Hopefully I'm pronouncing it correctly. I apologize if I'm not. That now I can reduce the energy that what did I do? I moved the energy up here. The likelihood of having to get into an enclosure with one overcurrent protective device, my service overcurrent director, the likelihood of me having to get in there is low. The incident energy is very high. If I have to get into this piece of equipment, I call the utility and tell them turn it off. Now, what Summit is saying is even on the medium voltage side, now this is on the low voltage side, but on the medium voltage side, I'm going to have a medium voltage distribution, and I can apply arc reduction technologies at medium voltage. Right now, the National Electrical Code has requirements for like in 24087, which we mentioned earlier, but that only applies to 1,000 volts or less than 1,000 volts. It doesn't apply to medium voltage applications. And the question is, why not? Do I not have arc flash issues on medium voltage? Now, one of the arguments that I've heard, which I think is a good one, is that working on medium voltage equipment energized is much less likely. People get nervous around 4160, 138 kV, 13.8 kV. They don't like to monkey with stuff that is hot. I can empathize with that. But still doesn't mean that I don't want some level of arc flash technology to reduce the damage should an event occur. So I am in your court, Summit. You just you got a friend in me. You got a friend in me. Fantastic video, Thomas. Thank you. That was on the single line diagram. I had a few comments on the single line diagram, and I just had a Wesco presentation I did yesterday, and I emphasized to these designers and others the one line diagram, critical, 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 critical. I can't emphasize it enough. Please, let's keep the one line diagrams updated for our electrical workers who have to work on things. And if they want to establish an electrically safe work condition, we want to help them facilitate that. Please put some money into the one line diagram. Summit says again, so Summit Mondale, if arc quenching switchgear or numerical relays with arc flash AFD detection feature is employed in all of the low voltage and medium voltage switchgear, then we do not need to break our head for lower arcing current with higher fault clearing time. So I think what he's saying is if we employ these technologies, then you don't have to sharpen your pencils and scratch your heads about how we're going to address it. And I agree and I disagree with that one. I think no matter what technology you're employing, you're still going to have to do an analysis to make sure that it's going to activate. Now, I do agree that if you have a technology like an arc quencher that will detect and detect the fault and clear the fault because of light and everything else that's associated with that arc flash event, then are you making a difference there with regard to reducing the energy and all that jazz because of the capabilities of it? Absolutely. You are making a huge difference. And can you put a little bit less thought? Probably, because that technology is going to be there for you. And I was just looking for my arc quenching video because I know I have that, I got to show that to you, because if you haven't seen it, maybe we'll end on that one, because from an arc quenching perspective, I got to go to NFPA. I got to go to 70E, my 70E presentation, NFPA, 70E presentation, and arc, that's hazard shock. I want to go to hazard, arc flash, and I think I have a video in this PowerPoint presentation. And I'm just going to double check. I hope all of you guys and gals out there are. Yep.
Danger lives.
All right. So that's the long version, but I'm going to show it anyway. Got a friend in me. All right. I'm going to. All right, let's take a look. I am actually, here we go.
Arc flash events. They are serious incidents that endanger lives, destroy critical infrastructure,
that is
and take vital
a
processes
significant amount of energy.
A variety of technical innovations and administrative controls exist to reduce the risk. But even those solutions leave people and equipment in harm's way. Never satisfied with the status quo, a team at Ever has been working on innovative ways to improve the safety of operators and protect the equipment they work on.
That's the arc quench. Hey, there's Adam.
That's Adams Baker.
He
works with the low voltage switchgear team at Eden.
This became our driving force and challenge. Reduce the incident energy from an arc flash event to a level rarely seen in our industry. In other words, someone needs to be able to stand next to our switchgear, and in the event of an arc flash, not just survive, but walk away unharmed. And we wanted a solution that protects the equipment too.
This, you may know, is a significant
That's
task.
significant.
Add it up. Even with the existing systems on the market today that reduce the risk of arc flash, there are nearly 30,000 arc flash incidents every year. The explosive force and intense heat produced by arc flash events injures thousands of people and kills hundreds. And arc flash events often destroy switchgear, leading to costly downtime while critical parts are repaired or replaced. A catastrophic arc flash event in low voltage switchgear can release 15 million joules or more of energy. That's like detonating nearly 2 pounds of TNT inside your equipment. Reducing or capturing that energy is the key to protecting personnel and equipment. For a 30-cycle arcing fault with no energy reduction or containment methods, the result is devastating. The explosive force decimates equipment, threatens the safety of operators and maintenance personnel.
Most methods for reducing arc energy rely on tripping the main circuit breaker to clear the fault. Unfortunately, low voltage power circuit breakers can take up to 4 cycles or 67 milliseconds to open. This is simply not fast enough. The ideal solution is a system that operates faster than the circuit breaker to reduce the incident energy even further. In fact, our team set out to develop a solution that reacts so quickly that the damage from an arc flash event is dramatically reduced or completely eliminated, not to mention what that would do for personnel safety.
There are 2 modes of equipment damage and personnel injury that result from an arc flash event.
The most obvious is the extreme heat, molten copper, and flames that are discharged during an arc flash. But before that happens, an equally dangerous pressure wave ruptures the enclosure and ejects shrapnel at high velocity. According to testing performed by Eaton, this pressure wave peaks at 7 milliseconds from the onset of the arc flash, or less than 1/2 of a cycle. So the system must operate at least that fast to provide maximum protection.
Eaton's arc-quenching switchgear was developed with that goal in mind. The technology is designed to detect and quench an arc flash event in less than 4 milliseconds. That's less than 1/4 of a cycle, well before the pressure wave reaches peak destruction. The team performed a 30-cycle arcing fault test at 635 volts and 85,000 amps of available fault current. And
3, 2, 1.
the arc-quenching switchgear survived undamaged. And had a person been standing in front of the gear, they would not have sustained burns or been injured by flying debris.
After an arc flash event, the Eaton arc flash relay indicates the location of the fault inside the switchgear. All you need to do is evaluate the equipment, remove the cause of the fault, and return it to normal operating condition. The time required to return the switchgear to service is reduced to a matter of hours instead of waiting weeks or months for repairs to be made. After the arc quenching device is triggered, it must be replaced. If you don't have a spare available, you can still re-energize your switchgear, but your protection will revert to the clearing time provided by the arc detection relay and the main breaker.
The result is dramatically reduced incident energy levels, which minimize or completely eliminate damage to the switchgear and yield superior personnel protection. Protection that meets or exceeds the IEEE C37.20.7 guide for testing metal-enclosed switchgear for internal arcing faults. Arc-quenching switchgear provides arc resistance without the need for ducts, plenums, special construction, or venting inside the room. And it maintains its arc-resistant rating even with breaker doors open and breakers removed. The system is always active when power is applied. It does not require any operator intervention when properly maintained. And it contains technology to prevent nuisance activations from the light emitted when an air circuit breaker interrupts a downstream fault outside the switchgear.
Here at Eaton, we're very excited to provide a best-in-class arc flash safety solution that provides superior personnel protection, advanced equipment protection, and dramatically reduced downtime in the event of an arc flash. With arc quenching switchgear, the future of arc flash safety has arrived.
Tell me that is not cool, huh? So, anyway, that is when you think about safety. When you think about what someone is saying, that when you provide technologies like that, the hazard goes away. And it makes a big difference for the electrical worker and for the facility's uptime and reliability. All right. Listen, it is after 1 o'clock. It's 1:05. I went 5 minutes over my time. Thank you for joining me for lunch. In your lunch, hopefully you had some lunch, and I've got a call at 1:30, so now it's time for me to eat some lunch and then get my call going at 1:30. So remember, please stay safe, stay healthy, take care, and remember the life you might save might be mine. All right? So thanks, everybody. Have a great weekend. Steve Froming in the house, Daryl Hill, Robert, Nihad El Sharif, Bill Snyder, William Snyder. Thank you for all you guys do for the electrical industry and electrical safety. And stay safe. And remember, please, please, please stay healthy. Take care.